Education is not the learning of facts, but the training of the mind to think. So let's learn and enjoy mathematics. Our lesson is about probability of dependent and independent events. What could be our first objectives? First, we will illustrate dependent and independent events. Second, we will find the probability of dependent and independent events. So what is joint events? It refers to the probability that two events will both occur. It also refers the likelihood of two events occurring together. As you can see in a Venn diagram, we have event A and event B. Event A joins event B. So this example is a joint event. Let us determine whether the event or events in each experiment is joint or are joint or not joint events. In example number 1, getting ahead in a flip of a balance coin. Do you think this event is joint events or not joint events? Correct, not joint events because only one experiment is done. How about the second one? How about the second one? Picking a red or blue ball from a jar with different color balls. Joint events or not joint events? Correct, not joint events because only one experiment, that is picking a red or picking a blue ball. How about example number 3? Drawing a red card first, then a black card next from a deck of cards. Joint events or not joint events? Correct. So this is joint events because two trials are done separately, one after the other. First is the red card and afterwards that is the black card. As you can see in the first two examples, this is not joint events because only one experiment is done, while the third example is the joint events because two trials are done separately, one after the other. Joint events could be dependent or independent. What is dependent events? Dependent events if the outcome of the first affects the outcome of the second event. In other words, in the problem, we will see the words without replacement, not replace, not return, and the like implies that the events are dependent. The formula for the dependent events is probability of A intersection of B. It is equal to probability of A times the probability of B following A. Let us see the different example of dependent events. In example number 1, you must buy a lottery ticket to have a chance at winning. Your odds of winning are increased if you buy more than one ticket. As you can see, this example is dependent events because the outcome of the first affects the outcome of the second event. So as you can see, they need increase. You need to buy more than one ticket. How about example number 2? This example number 2 is dependent events because, as you can see, committing a serious crime such as breaking into someone's home increase your odds of getting caught and going to jail. So there's an increase that you commit a serious crime, you are getting caught or going to jail. So if the outcome of the first affects the outcome of the second event. How about independent events? Independent events, the outcome of one event does not affect the outcome of the second event. In other words, two events have nothing to do with each other. So the formula for the independent events is probability of A intersection of B. It is equal to probability of A times the probability of B. The different example of the independent events is this one. Taking an Uber ride and getting a free meal at your favorite restaurant. As you can see, these two events, the Uber ride and getting a free meal, those two events have nothing to do with each other. How about example number 2? Growing the perfect tomato and owning a cat. As you can see, perfect tomato and owning a cat, these two events have nothing to do with each other. So let us classify the following joint events from the different experiment as dependent or independent events. In example number 1, rolling a pair of dice. Dependent events or independent events? What do you think? Okay, correct. So that is independent events. The outcome of one does not affect the other outcome. In example number 2, drawing two cards in succession from a deck of cards without replacement. So do you think this is dependent or independent events? Correct. So this is dependent events because the drawn card is not replaced or returned. As you can see in the given, the word is without replacement, so it means that is dependent events. How about number 3? Drawing two cards in succession from a deck of cards with replacement. Dependent or independent events? Okay, correct. So that is independent events because the drawn card is replaced and returned. If this is without, that is dependent. But in this given, with replacement, so that is independent events. Example number 1 and number 3 is independent events because does not affect the other outcome. While the second one is dependent events because it affects the other outcome. In example number 1, if a die is thrown twice, find the probability of getting 2 fours. This example is an independent event. Let us see what could be the given. So in event A, we need to get the probability of getting 4 on the first throw. So 1 and then out of 6. How to get 6? In a die, we have 1, 2, 3, 4, 5, and then 6. How about the event B? The probability of getting 4 on the second throw. So that is 1 out of 6 because in a die, that is 1, 2, 3, 4, 5, and 6. We need to identify now the probability of getting 2 fours. So let us get the probability of A intersection of B. The formula is probability of A intersection of B. It is equal to probability of A times the probability of B. The probability of the event A, that is equal to 1 over 6, while the probability of the event B times 1 over 6. Let us multiply. 1 times 1 is 1. 6 times 6, the answer is equal to 36. So the probability of getting 2 fours is equal to 1 over 36. In example number 2, consider a box that contains 14 blue balls and 12 green balls. A ball is drawn at random and the brand is noted and then put back inside the box. Then another ball is drawn at random. Find the probability that both balls are blue. So this example is independent events. So let us see what could be the given. So the given, that is the event A, the probability of blue balls on the first draw. So that is 14 out of 26. How to get 26? 14 plus 12, that is equal to 26. How about the event B? The event B is another balls, the blue balls. So blue balls on the second draw. So that is equal to 14 out of 26. So let us find now the probability that both balls are blue. So the probability of A intersection of B. The formula is probability of A intersection of B. It is equal to probability of A times the probability of B. The probability of the event A of the first draw, that is equal to 14 over 26. While in the event B, the blue ball on the second draw, that is equal to 14 over 26. So let us multiply. 14 times 14, that is equal to 196. 26 times 26, that is equal to 676. The lowest term of 196 over 676, we need to divide it by 4. 196 divided by 4 is 49. 676 divided by 4, that is 169. So the probability that both balls are blue is 49 over 169. In example number 3, a jar of marbles contains 4 blue marbles, 5 red marbles, 1 green marble, and 2 black marbles. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. Find the probability of picking a blue and then a red marble. So this example is independent events. So let us see what could be the given in event A. Event A, that is the probability of the blue marble. So that is 4 out of 12. How to get 12? 4 plus 5, 9 plus 1, 10 plus 2, that is equal to 12. How about the event B? The event B, that is the probability of the red marble. So the red marble is equal to 5. 5 out of the total number of possible outcomes, that is equal to 12. So let us find now the probability of picking a blue and then a red marble. So the formula is probability of A times the probability of B. So the probability of the event A, that is the probability of the blue marble, that is equal to 4 over 12. While the probability of the event B, that is the red marble, that is equal to 5 over 12. So let us multiply. 4 times 5 is 20. 12 times 12 is 144. The lowest term, that is equal to 5 over 36. Because 20 divided by 4 is 5. 144 divided by 4 is 36. So the probability of picking a blue and then a red marble is 5 out of 36. In example number 4, a coin and a die are tossed simultaneously. What is the probability that the coin will land on head and the die on less than 3? So this example is independent events. So in a coin, we have head and tail. In a die, we have 1, 2, 3, 4, 5, and then 6. So let us see what could be the probability of getting a head. The probability of the getting head is equal to 1 out of 2. How to get 2? Because in a coin, we have head and tail. How about the event B? The event B, that is the probability of less than 3 in a die. So less than 3, that is 2 and then 1. So that is 2 out of the total number of possible outcomes in a die. That is 1, 2, 3, 4, 5, 6. So 2 out of 6. So let us find now the probability that the coin will land on head and a die on less than 3. So the formula for the probability of A intersection of B, it is equal to probability of A times the probability of B. The probability of the event A, that is the probability of head, that is equal to 1 over 2. While the event B, that is the probability of less than 3 in a die. So times 2 over 6. So if we solve, cancel 2, that becomes 1 times 1 is 1. 1 times 6, the answer is equal to 6. So the probability that the coin will land on head and a die on less than 3, that is equal to 1 over 6. In example number 1, a card is chosen at random from a deck of 52 cards. Without replacing it, a second card is chosen. What is the probability that the first card chosen is a king and the second card chosen is an ace? So this example is dependent events because there's a word without replacing it. So let us see what could be the given in an event A. In event A, we need to get the probability of getting a king. Getting a king in a first pick, so that is equal to 4 because that is the spade, the heart, the diamond, and the club. So 4 out of 52 because in a deck of 52 cards. So 4 out of 52. How about the event B? The event B, we need to get the ace. So the ace in a second pick. So that is ace in a diamond, in a heart, club, and then spade. So that is 4 over total number of possible outcomes minus 1 because the problem there is without replacing it. So 52 minus 1, that is equal to 51. So let us find now the probability that the first chosen is king and the second card chosen is an ace. So let us find now the probability of A intersection of B. The formula is probability of A intersection of B. It is equal to probability of A times the probability of B following A. The probability of A, that is equal to 4 over 52, multiply it with the probability of B following A, that is equal to 4 over 51. 4 times 4, that is equal to 16, all over 2,652. And the lowest term, that is equal to 4 over 663, because 16 divided by 4 is 4. 2,652 divided by 4, that is equal to 663. So the probability that the first card is chosen as a king and the second card is chosen as an ace, that is 4 over 663. In example number 2, consider a box that contains 14 blue balls and 12 green balls. Suppose that 2 balls are drawn, one after the other, without putting back the first ball. Find the probability that both balls are green. As you can see in this problem, there's a word without putting back, so that is dependent events. So let us get now the event A. And event A, that is the probability of getting green in a first pick. So that is 12 out of 26 because 14 plus 12, that is equal to 26. How about in the event B? The probability of getting green in a second pick. So that becomes 11. Why 11? Because based on the problem, without putting back the first ball. So 12 minus 1, that is equal to 11. Also, the total number of possible outcomes because without putting back the first ball, so that becomes 26 minus 1, that is equal to 25. Let us find now the probability that the both balls are green. So let us represent it with the event A and event B. So the formula, it is probability of event A times the probability of B following A. The probability of the event A, that is equal to 12 over 26, while the probability of B following A, that is the second pick of the green balls, that is equal to 11 over 25. So let us multiply. 12 times 11 is 132. 26 times 25 is equal to 650. And then the lowest term divided by 2, that is equal to 132 divided by 2, that is 66. 650 divided by 2, that is 325. So the probability that the balls are green, that is equal to 66 over 325. In example number 3, a class is composed of 10 boys and 15 girls. If two presenters to a poem recital are to be chosen in succession, what is the probability that the first is a boy and the second is a girl? So this example is dependent event. So let us see the event A. The event A, we need to get the probability of the boy. So that is equal to 10 out of 25 because 10 plus 15, the total number of possible outcomes, that is equal to 25. How about the event E? The event B, that is the probability of the girl. The girls is equal to 15 out of 24. Why 24 in the denominator of the probability of the girl? Because in succession, ibig sabihin nun magkasunod. So ibig sabihin kung magkasunod, so nauna na yung boy, another is girl. So 25, we need to subtract it. 25 minus 1, that is equal to 24. Let us find now the probability that the first is boy and the second is a girl. So let us find now the A intersection of B. The formula, it is probability of A times the probability of B following A. In the probability of the boy, that is event A, that is equal to 10 over 25. Multiply it with the probability of B following A. So the probability of the girl, that is equal to 15 times over 24. So let us multiply. 10 times 15 is 150. 25 times 24, that is equal to 600. And the lowest term, that is equal to 1 over 4. Because 150 divided by 150, that is equal to 1. 600 divided by 150, that is equal to 4. So the probability that the first is a boy and the second is a girl, that is equal to 1 over 4. In example number 4, a box contains 9 pieces of number balls. If 3 pieces are taken from the box one at a time without replacement, find the probability that they are alternately taken. As you can see in this problem, we have the word without replacement. So it means this is dependent events. So what could be the formula for the dependent events? That is the probability of A intersection of B. It is equal to probability of A times the probability of B following A. As you can see, we need to find the probability of add, even, and add. So that becomes probability of add, even, and add. So add intersection of even, even intersection of add. So what could be the value of the adds? The add number in the 9 pieces of number balls, that is 1, 3, 5, 7, and 9. So we have 5. 5 out of 9. Why 9? Because in a box contains 9 pieces of number balls. How about the even number? The even number, that is 2, 4, 6, 8. So we have 4 all over 8. Why become 8? Because in the problem, without replacement, so it means we need to subtract the denominator by 1. So 9 minus 1, that is equal to 8. How about the odd number? So the odd number, that is 1, 3, 5, 7, and 9. So we have 5. But then, given na yung first odd number, so nakuha na rin yun. So 5 minus 1, that becomes 4. And then the denominator subtracted by 1 because the problem without replacement. So 8 minus 1, that is equal to 7. So let us solve. 5 times 4 times 4, so that is equal to 80. And then 9 times 8 times 7, that is equal to 504. The lowest term of 80 all over 504, that is equal to 10 over 63. Because 80 divided by 8 is 10. 504 divided by 8, that is equal to 63. So it means the probability of add, even, and add, that is equal to 10 over 63. How about the probability of even, add, and even? So the formula is probability of A intersection of B. It is equal to the probability of A times the probability of B following A. So as you can see, we have the even intersection odd intersection even. So in an even number, we have 2, 4, 6, 8. So that becomes 4 all over the total number of possible outcomes, that is equal to 9. The odd number, that is equal to 1, 3, 5, 7, 9. So we have 5 all over. Subtract the denominator by 1 because in a problem that is without replacement. So 9 minus 1, that is equal to 8. In an even number, that is 2, 4, 6, and then 8. But then given na yung first even number, so let us subtract the 4 by 1. So 4 minus 1, that is equal to 3. And the denominator, because the problem is without replacement, 1 at a time. So 8 minus 1, that is equal to 7. So let us solve. 4 times 5 times 3, the answer is equal to 60. 9 times 8 times 7, that is equal to 504. If we get the lowest term of 60 all over 504, that is equal to 5 over 42. Because 60 divided by 12 is 5. 504 divided by 12, that is equal to 42. So the probability of even, add, even, that is equal to 5 over 42. Instruction: give the probability of the following questions. Provide your answers in the comment section. Enjoy learning mathematics. I'm Teresa Tubal. Thank you so much.